Alright, so now let us discuss this common drain circuit with non-idealities, and we'll try to understand the circuit intuitively. So in case of ideal situation, we have already discussed in this video that this current, this incremental current, it doesn't find any path to flow. So in that case, this current has to be zero. But in this case, with all these non-idealities, this current has two paths to flow, one through the R naught, another through the capital R naught. All right. So in this case, your GM VGS is not zero, and you can say that VGS is not equals to zero. Now, while discussing the common drain circuit, we saw that this voltage gain is less than 1. This voltage gain is less than 1 uh, or approximately equals to 1 when if you ignore R naught. So, but in general, this is, you can see it is less than 1. Okay. But the question is, can you intuitively explain this thing from the circuit point of view? Definitely, we can explain. So, for example, let us first consider a situation when this incremental voltage is greater than the incremental voltage of Vi. Okay, let's say V out is slightly above than the Vi. In that case, what will happen? Your VGS is negative. VGS is negative means the current is going in this direction. Okay. Now, what about the current through the R naught, small R naught and capital R naught? So here also it is going in this direction because this is grounded incrementally and this is also incrementally grounded. So here also current will flow in this direction. Okay. So if you look at this particular node, from this node all the current is going outward, right? So that is actually not possible. There's some current should come to that node and some current will leave the node. So in that way we can say this is a realistic situation. Okay, so it means if we consider this V out is slightly or it is greater than the V in, so that is not a real situation. But if it is less than the V in that case, this is the current direction. So it is going in this way, and for this voltage, particular voltage, this current is going in this way, and this current is going like this. And you can say this is a real situation, and that's why your V out is actually less than the Vi, and your voltage gain is actually less than 1. Okay. Now we can quickly calculate the voltage gain from input to output side. Basically, if you apply KCL over here at this node, so it has three current components. Okay, one is that GM times Vi minus V out. Another is this V out by R naught. So this is basically output node. So this is V out by R naught, and this is V out by capital R naught. Okay. So if you just apply that equations over here, and you will directly get the expression for the voltage gain. Okay. So that is basically GM by G naught plus small gm plus capital G naught. Okay. And if you apply the ideal situation, like your R naught is capital R naught and small R naught is infinity, in that case it will be simply equals to, the voltage gain is simply equals to 1. Okay, so that is pretty simple. So but this intuitive understanding is very important. Okay, that will help you a lot in while dealing with the circuit in future.